Okay, so since we do not have class today, I will start by first going over 3 problems using some intense math. Now, before you're like, whoa, 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 these are crazy. These problems were asked on last year's test. So, these are things that all utilize what we've been learning on this first chapter. So, with that in mind, we'll go through this. It's going to use dimensional analysis. Going to use some Fahrenheit to Celsius to Kelvin. Going to use some density. Going to use some significant figures. So let's try and work this through. If at any point, pause the program, see if you can figure these answers out before I do. But I'll go through them exactly as I would work them out. So, first problem. Very nerdy. If Bilbo Baggins traveled 950 miles from Bag End to the Lonely Mountain, canonically, at least in 172 days, what was his approximate speed in meters per hour? Now, mind you, there's times where he slowed down. There's times where he stopped in, like, Rivendell for a while. There's times where they flew on the backs of eagles, so the average speed is not necessarily consistent. But with his approximate average speed, so what do we got to do? 1, we are taking a distance and a time and finding a velocity. A velocity, so meters per hour, so we have to have m over hr as our final units. So I'm going to start with 950 miles over 1. Then I'm going to divide by 1 over 172 days. That's going to give me a unit in miles per day. But that is not what I desire. So I need to do some conversions. So before you're like, oh God, I don't know none of these conversions. Well, on the test, I gave you all the conversions you could possibly need. I gave you, for example, miles to feet, feet to inches, inches to centimeters, and then you could have gone 2 meters from there. But I also conveniently gave you this conversion. 1 mile is equal to 1.609 kilometers. That's a much easier conversion. Miles over miles. Those cancel out. However, I want meters. So the next conversion, let's see, I'd be multiplying by, in 1 kilometer, there is 1,000 meters. Kilometer cancels kilometer. So I have now meters per days. However, I do not want days. I want hours. So because there's days down here, I'm going to need days up here. 1 day contains 24 hours. Day, day. And we're left with meters and hours. Now the last step is just a matter of multiplying. So 950 divided by 172. I'm going to multiply by 1.609, multiply by 1,000, but then divide by 24. I'm going to hit equals. The average speed, or approximate speed, would be 370. Well, we can leave it as that. It would be 0.288, but 370 meters per hour. 370 meters per hour. And that would be that problem. So I would have given you the conversions, but I would not give you an equation. You would have to think about that, how you would set that up. But I gave you all the conversions you'd need. Now the next problem. Iron melts at 2800 degrees Fahrenheit. What is the temperature in Kelvin? Well, I gave them two equations. Fahrenheit equals 9/5 C plus 32. And I gave them K equals C plus 273.15. So the first step is to solve for my C. I'll say 2800 equals 9/5 C plus 32. So the first thing I would do is I would subtract 32 from both sides. So when I subtract 32 from both sides, 2800 minus 32, I get 2768 equals 9/5 C. Now, to get C, I would need to get rid of the 9/5. So to do that, I would multiply both sides by 5/9. 5/9 is going to cancel out that on that side. So 2768 5/9 is going to give us my Celsius is equal to 1537.7 repeating. Okay. Now the last step is now I have to find Kelvin. Well, Kelvin is equal to Celsius 7, well, let's say 78 plus 273.15. So I add my 273.15, and my answer is, in Kelvin, it is 1810.93 Kelvin. 1810.93 Kelvin. So as I said, I just need to solve for my unknown. Now this one I greatly abbreviated it, but the problem is essentially we are weighing out a sample. We are trying to find the density of an unknown. To do that, we need to first find its volume and then find its mass. So scientists adds 25.20 milliliters of a liquid to an empty beaker weighing 305.7394 grams. The total mass, so the mass of the solution plus the beaker, is 308.9020. What is the density of the liquid to the correct number of significant figures? So the first step is to find out what is the mass of the liquid, because density is mass over volume. Now what most people did, and they got it incorrect, is they took either of these two numbers and divided by my volume, which is incorrect. This is not the mass of the liquid, this is the mass of the beaker. This is not the mass of the liquid, it's the mass of the beaker plus liquid. So to get the mass of the liquid, you need to think this out. 308.9020 minus 305.7394. So the mass of my liquid is the difference between these two numbers. 9020 minus 305.7394, and we get 3.1626 grams. So that is my mass of liquid. Note, 1, 2, 3, 4, 5 sig figs. They both end at the 4th decimal place, so we'll keep to the 4th decimal place. So we have 5 sig figs. Now density is mass divided by volume. Well, our volume is measured to the 2nd decimal point, meaning this is 4 sig figs. So as I divide this by 25.20, I can only keep 4 sig figs. However, my answer is 0.1255 grams per milliliter, and that would be 4 sig figs. So I don't need to change that any. So 0.1255, you don't need to add a 0. You keep it to 4 sig figs. 1, 2, 3, 4. 1, 2, 3, 4. We don't round it to 126. We don't round it to 0.13. We leave it at 0.1255. That in mind, that's not a particularly hard problem as long as you're reading this carefully. If you're skimming it over and not really thinking, you're just grabbing the first number, you're not going to get it right. So that's one thing to watch out for. Watch out for problems where you need to do, or you have to modify your answers to get it right. But this is the problems I wanted to go through. So here's the first set. Now I will continue with another video in a few minutes about Chapter 2.